Hi, welcome to Hashtag Math. We're going to derive trigonometric functions now. We're going to add a few new derivatives to our table. It will all make sense. So the first thing we can do on derivatives of trigonometric functions is the graph. We are going to graph the derivative of the sine right here. So the first thing is, let's see where we have horizontal tangents. We have two here, where the function peaks. One at pi over 2 and one at 3 pi over 2. That means my derivative at pi over 2 is 0, and my derivative at 3 pi over 2 is also 0. The derivative here is very close to the line y equals x, and then we see that the derivative is positive because this line have positive slope, so we're above the x-axis, but the slope starts decreasing and decreasing and decreasing until 0. So we start with a slope of 1 and end up with a slope of 0 for that little piece. Then my tangent line starts having a negative slope and a negative slope and a negative slope until we reach pi. As we get close and close to pi, we get very close to the line y equals negative x, whose slope is negative 1. So we come from a slope of 0, and then my slope is decreasing until we reach negative 1. After pi, what happens is my slope goes down. It's going to be below the graph, like that. Still negative, negative, but increasing. You see, it's approaching 0. It's a negative number approaching 0. And at 3 pi over 2, we're at 0. So it is increasing all the way to 0. And after 3 pi over 2, our slope starts being positive again, and increasing until we get to pi over 2, where again we are very close to the line y equals x, whose slope is 1, and then my slope increases all the way to a slope of 1. Now look what we got. What function is this one here? The derivative of the sine is 1 at 0, negative 1 at pi, 1 at 2 pi, and 0 at pi over 2 and 3 pi over 2. That's nothing but the cosine of x. So by the graph, we found that the derivative of the sine is the cosine. Now let's do it algebraically. So to derive the sine, we have no rules to apply, so we have to go by definition. d dx, the derivative of the sine, is going to be the limit as h approaches 0 of sine of x plus h minus sine of x over h. Okay, sine of x plus h is a trig identity. This is the trig identity for the sign of the addition of angles. It says that sine of x plus h equals sine of x cosine of h plus, and now invert them, cosine of x sine of h, and we keep minus sine x here. Stare at the equation and see what can we do. What do you think you can do here? Like, there's not a common factor among all of these terms. What we can do is factor sine x from the first and third term. So this is the limit as h approaches 0. And let's factor sine x from here. We're left with cosine h. And from here, and we're left with negative 1. And just keep the middle term. At this point, let me refresh our blocks. We know that the limit as h approaches 0 of sine of h over h is 1, and we also know that the limit as h approaches 0 of cosine h minus 1 over h is 0. We want to rearrange our equations to find those blocks. Can you see them? I can see one block forming here, another block forming here, and it's just a matter of splitting the limit. So let's split the limit. This is the limit as h approaches 0 of sine x times cosine h minus 1 over h plus the limit as h approaches 0 cosine x sine h over h. The limit is taken as h approaches 0. So for that limit, sine x is a constant, and we can pull it out to the front. We get sine x times the limit as h approaches 0, and you see we have our little block right here. Plus, the same thing happens here. Cosine x is a constant for the limit, and we can pull it to the front. We get cosine x times the limit as h approaches 0, and my nice block is here. Now you know what's happening. This limit is 0, and this limit is 1, and the only remaining thing is the cosine of x. So the derivative of the sine is the cosine. So we graphed it and found it algebraically. The same thing we can do for the cosine. We can find the derivative of the cosine by definition. At the end, we get this table. The sine of x is done by definition. The cosine of x is done by definition. And then, using those two derivatives, we get the derivative of the tangent, the secant, cosecant, and cotangent. These are things you have to memorize. The derivative of the sine and the cosine, it's very easy to memorize. Then you memorize the derivative of the tangent and the secant. And as you can see, the cos are going to be the same thing, but with a negative sign. You memorize the derivative of the tangent is secant squared. So the derivative of the cotangent is cosecant squared with a negative sign. Let's do this example now. We want to find the derivative of sine x times tangent x. And of course, we're going to use everything we know so far. In order to derive any function, you have to see the operations going among the functions that form the expression. In this case, we have sine x times tangent x. So the operation joining the two functions that we have here, a product. So we must apply the product rule. We apply the product rule to derive y. Keep the first, derive the second, plus derive the first. Sine x stays the same. The derivative of tan x is secant squared x using the table. The derivative of the sine is the cosine, and we keep tan x. At the end, you always try to simplify your answer. The only thing I see we can do here, like sine x, secant squared x, we cannot simplify because secant squared is going to be 1 over cosine squared, and sine over cosine squared doesn't look better. But here we have cosine x, and then tangent x is sine x over cosine x. And my cosines simplify, and that looks better. So my answer is going to be sine x secant squared x plus sine x.